recording? Yeah, there we go. The audio on all the recordings will sound terrible because I'm speaking through a mask in the microphone. It's just a matter of dealing with things, a matter of life at this point. So that package that's there will show kind of this version. It's a little more fleshed out. Took a little bit more time. The afternoon class always has a little bit of an advantage that I've gone through things once and kind of can add a little bit more, but the ideas are still the same. It's just more buttons I took more time with. So we have, if we'll remember from last time, we were adding buttons to the Unity interface, right? So we were able to go over here and type, or click, right-click, and we were adding these UI elements, such as buttons, Text Mesh Pro, or legacy buttons, or text, or whatever kind of UI elements we want. They're being added to the canvas. These are all part of our heads-up display. Our first game is really all about the heads-up display, all about our interaction. So we added bunches of buttons this way, and then the key thing we were looking at was how these buttons were connected via their on-click event to a method, a function, a method that is part of this game manager class, or this game manager component that lives on this game manager object that we created in the game. All right, so just to kind of review the structure of our game, we have the game manager, which is the thing that sort of has all the important stuff on it. It has the one script for now that we're going to be working in. All right, so your project should only have one script in it, and all of the logic, all of the code, for now, in the future we'll have a lot more than one script. But for now we have, one script that has a start, where once the game starts playing, we'll start sweating up a storm up here. Once the game starts playing, that start routine is called. It's kind of like our main. If you're familiar with other programming languages, we have to have somewhere to start. So start is sort of the equivalent of main. And then we have other functions that we're creating, other methods of our component class that we're going to use for events such as, our on click here and our on operation. All right, so plus, minus, equals, division, multiplication, so on. Those are the things that are buttons that trigger the on operation method versus the buttons that have the on-click event. Those are kind of the ones that are allowing us the numerical input. Now, I believe in the morning last time when we did this, we were only able to type single digits. Is that right? You couldn't have tens, hundreds, thousands, and so on. So one thing I did and demonstrated and added the ability to add tens, hundreds, thousands, and so on, all through 2 lines of code. So to kind of demonstrate that code doesn't have to be long and complicated. We just have to figure out the proper algorithm to use for the proper situation. So for example, here you'll see this little line, A equals A times 10 plus val. And there's the corresponding one, B equals B times 10 plus val. So what happens there, like the other time around, every time we pressed a key, that would become our new number. A and B, those were our operands, right? Remember that? Our operands versus our operation. Our 2 operands, we're doing simple math here. We have an A and a B. They want to equal something in the end. So instead of just setting our A and B to the value we're passed here, we multiply whatever is already in that operand by 10. So if 1 was there, we multiply it by 10, it becomes 10, and then we add the new number to it. So if I typed 1, it would put 1 in because initially it would be 0. 0 times 10 is 0. I press another button, I press 3, it says, okay, 1 times 10 becomes 10 plus 3 equals 13. Right? Not particularly complicated. Nice 1 line of code, and voila. I have the ability, certainly it's a far more useful calculator if it can handle more than 0 through 9. All right? Now, I do have to be a little bit more careful, though, of course, because at some point I may need to set this number, A or B, back to 0, because I can't just leave whatever's there kind of lingering around, right? So what happens here, and this is buzzword for you, not going to be tested, not part of a quiz or anything like that. What this operation sort of becomes is sort of, it uses an add with accumulation, right? So we have a variable that's kind of hanging around, and we're going to use that variable to accumulate things. We're going to add to it, so it's constantly being added to. So you can think of things like HP and score, as these sort of operations that hang around, or these variables that hang around that we have to add to, subtract from, and so on. So we need them to be around. We need them to be persistent. Generally, they're going to be part of a class, so they're not a temporary or local variable, right? We talked about those things. And so this is a little bit more sophisticated. That's in the code. That's in the package for you to check out and try. The other big thing that we added, I'm not sure, we didn't do multiplication in the morning, did we? Did we? I'll go back and look at the video. And if you answer wrong, we didn't do multiplication. So what I decided to do is combine both, we talked about for loops and while loops and so on. And I figured, well, pedantically, just will be silly. And to demonstrate multiplication as a for loop, why not? So we had, we added, let's see, we did have plus minus there, but we added multiplication by using a for loop. Because after all, what is multiplication but adding something over and over again, multiple times, right? So if we loop over it and we add, so if I wanted to say multiply 3 times 10, it means doing that 3 plus 3 plus 3 plus 3 plus 3 10 times. Sounds a lot like a loop. One way of doing it, right? So what we have right here is multiplication as a for loop. We start off, we set some value 0 here, and now this temp is our accumulated value that we're going to use. So each iteration through the loop, we're going to be adding and adding and adding until we accumulate enough copies of B here that are all added together to form our multiplication. All right, so that's what's going on in there. We also incorporated a switch statement in there. All right, we talked about switches where we said, all right, we want to look at potentially multiple types of input and make a decision based on the number that we're passed. We don't have lots of ifs and thens and so on. So instead, we just say, all right, a value comes in, and I know I want to do one of 3 operations. Perhaps eventually, if I had divide in there, it might be one of 4 operations. So that seems like a good instance of using a switch statement, right? This code if it's this code if it's that, this code if it's this, and simplify as opposed to having a crazy if-then or if-else sort of thing, right? That's what's going on in here. We have a state or a case for addition, a case for subtraction, a case for multiplication, and it's all switching on that value that is being sent to this method, right? You remember we were getting our value here is coming in, and that's what we're kind of switching on, right? Now, wanted to talk a little bit more about this line here as well. We added this concept, started to talk about it, I think, a little bit. The idea of an enumerated type. The types we talked about when we were initially talking about C# were things, types like integers, floats, even had structures and classes. These are all types of variables that we can use to define data structures and so on. There's another type called an enumeration or enumerated type. I'll formalize this a little bit. The enumerated type is simply a lot like an integer, but it's an integer that can only take certain values. So I kind of predefine values that this particular integer can be. Useful for things like, if I needed to say the day of the week or some specific operation within some subset or some operation that is one of a set of operations like this. So you see here, it's defined public enum. That's saying, okay, I'm about to define this enumerated type. I give my type a name. I'm calling this my op for my operation. Could be anything. And then I list the possible values. And these are going to be things I can refer to as names as opposed to 0, 1, 2, 3, 4. Because so you can imagine referring to something as mult is more meaningful to me as the reader than if such and such equals 5. because I didn't remember what 5 was, or maybe whatever. It makes life easier, makes coding more precise, and so on. Okay? So this is the setup of an enum. This is declaring the type. This is actually declaring a variable of that type. So it's a lot like just saying, I could have said public int operation, but instead I said public myop operation. So it's one of those special integers that has certain values that it can take. And then I can use that enumeration in things such as these sort of operations where I know that the value is going to be one of those things. Right? Like the key press for the operations. Yes? It's a very good question. It's a little bit tricky because if we were strictly scripting, if we're strictly doing it within C#, we would probably want to use the enumerated type, so it would be clear on that. Now, since we're in Unity in the IDE, and over in Unity in the environment, it doesn't really know about that, right? We can't tell Unity, like for example, here specifically, we'll go to one of our numbers here, right? I can't type in myop dot. I'm going to assume I've never tried it. Well, I don't want to break everything, but the assumption, I think my assumption has been that you need to. This is one case where you need to kind of remember where it is. If you try it and it works, let me know, because maybe Unity changed that, made it a new feature. All right, so that normally that's one of these things where you're going back and forth between a GUI integrated development environment versus a more traditional language like that. Okay, so we have to be a little bit careful. Pass the number, yeah. But if we were passing it from another script, another actual method in there, we could refer to it, using the myop. It would be better to kind of strictly do it that way. Right. Okay. So let's change gears for a moment now that we've kind of discussed what's there, reviewed that code a little bit, and jump back to the syllabus again. All right. So after reviewing a lot of the projects, I think I'm almost done with a few more that I have to do in between the classes to get out to some people. One thing really occurred to me: a lot of people like the idea of having multiple rooms, and your ideas are a lot more ambitious kind of than the typical thing that we do in terms of just one room. Let's check some boundaries and let's keep it kind of simple. And instead, people want to do things like, well, I have lots of objects in the room, or I have a bunch of enemies, or I have, a map that has, different worlds I can explore. And a lot of feedback is, well, think simple. Think, okay, there's one object, one room. That's easier to deal with. Yes.
So you said we have to handle the player moving.
Yes.
So would we need multiple rooms, like rooms in and out of?
Potentially, yes. Yes. So that's where it gets challenging, right? If we want to have multiple rooms, well, how do we deal with these multiple objects, right? How do we deal with, on the one hand, some people also ask, can I just, or they wanted to use a grid system, and let's see. Imagine, you were designing your game, and you said, here's my sketchpad here somewhere, and I decide, okay, I want to design a maze. There are quite a few maze ideas out there, where you want to be able to lead the player through something that's like this. They start off here, and they let's give them. They want to wind up leaving over here. And as you can imagine, that's kind of tricky. That's kind of, as you wander around in there, what kind of data structures would you use for that? Right? Yes? You could. You could use a 2D array, but that's not what I want you to do. Right? Why? Because that's not what most of the game engines that you're going to deal with do. Modern game engines don't think in those terms.
We're going to have to stop possession. Is it then fine if we use an empty object to be able to?
Yes. Okay. So the lecture today, once we actually jump into the lecture, we'll see some specific values. So those, one of the things is, okay, how do you move around in there? One of the approaches, the traditional kind of old school approach would be, for a lot of these games, right, the true Enter the Wumpus, sort of once upon a time, is that you would have thought of this whole world as, say, an integer array, some sort of array. And this is why I want to be here in person, because it's awesome artwork that I'm generating here. You can imagine that we have this array of values in memory somewhere that's 0, 0 at this corner, and maybe is 16, 16 in this corner, right? So if you're familiar with two-dimensional arrays that have an x and a y value, and we say, well, let's just move the user around and say, oh, is this a valid square to be on? Because we have an array that says it's number 0, so we can be there, versus if this was a 1, we can't be there, right? So you could design a world where it was 1, 0, 1, 1, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 1. We'll just make all these ones. Right? Everywhere there's somewhere you can't move, there's a certain value. Everywhere you can move, there's another value. So this should have been 0. Sorry. Those should be zeros. Anywhere you can go, there's a 0 in the array. And every time the player wants to move, you just change their x and y value to where they are on the map. And you check, is that a valid place to be? What is in that place? And if there's a monster there, maybe there's a 2. Right? You see, oh, if it's 2, there's a monster there. But game engines like Unity, Unreal, Godot, just basically anything you're likely to come across, any legit game engines these days, we typically don't use that approach. We're using something where the player is an object, the player has some position. So we have player, and that player will have some sort of vector2 probably that has an x and a y value that tell you my location in the world, right? And the question of how you design this becomes a little bit more difficult. You're like, well, okay, do I have an object for every one of those? Or do I, what really happens is you're going to do things like, well, it's likely that you have something that is either walls or hitboxes or something that then defines the world more specifically. And this is something that is a 4x4 hitbox located at some position, -1, -1, right? So that becomes somewhere you can't enter there because there's stone there. There's an object there. There's something in the environment. Or maybe there's, more traditionally, it might be, okay, here's a wall, here's a wall, here's a wall, and so on. And we define those walls as objects. Or sometimes we use tile maps that have them divided as well. Yes? No, the player should still. There's still no graphics, right? So let's jump into the. So this is the challenge we face, right? This is the problem. So we'll keep this in our minds, and let's talk about. Let's go into the lecture notes, and hopefully we'll get to the point where it makes more sense then. Let's see if I got the right one open here. Yes. Okay. So last time around, for the most part, what we wanted to get to is the point where we attached methods from our game manager script to the on events or broadcasters of the UI buttons and the toggles, right? UI elements will have some sort of event that they can raise or cause, and we can attach that to our script, right? So we have that one game manager script. There should only be one object that has a game manager component on it, which is our game manager object that we created. So it shouldn't be attached to anywhere else. It should be one instance of it, one thing, one ring to rule them all, as they say, right? And we're triggering things in that one script according to the objects that are there, okay? On click, on value changed. And we're always calling these things in our, like here it's called manager, game manager, something like that. Now, eventually we're going to go beyond that. We're going to be even having objects in the games that we're really going to take advantage of this. But for now, I want to keep things localized in one spot so we can kind of concentrate on it. All right? So UI entities themselves are objects that own the components that contain properties and methods that can be accessed by others. We know that, right? Everything in Unity is an object with components on it. Okay? Went through this a little bit in terms of when we want to find a reference to another object that's in our scene or in our game. We have a couple of different ways to do it. The brute force way to do it is we ask the game object class to find an object in our scene, right? An active object, and we give it a name, the name that's the string, the name that we named it, right? So if I needed to find the message box, I could ask the game object class to find a game object named message box, right? So we're using a feature of the class to find that. That's one way of doing it. The other way to do it is that we can do our drag and drop approach, where we can just say inside of our script we have a public game object, maybe it's feedback text, and we just don't bother to do this game object.find, and instead, because it's public, we can kind of drag and drop it in the Unity editor. Right? Does everyone remember that part? Right? So we have two ways of doing it. Ultimately, there's a game object reference to whatever that text is that we want to work with here. Feedback text, right? That's where we want to put the text. So that's a game object. We find the game object, and then we're going to have to go a little bit deeper down to find the component on that object that is the actual text component, right? So this is the next step down. This is the legacy text version in here. Okay, so this isn't the Text Mesh Pro version. If you want to see the Text Mesh Pro version, the sample code in the calculator has it that way. It's a little bit different. You just have to make sure that you've got the appropriate headers defined or headers included, using TM Pro, and then you can refer to Text Mesh Pro UI GUI UI. I forget there. Right? You have to make sure to look for the Text Mesh Pro text component and not just the generic legacy. Right, but same idea, right? So game object.find foo get component of whatever type, and then we can ask it about its properties and so on. Right. Now, pro tip, as you get more advanced in this, as you get more game objects, as you want your game to be more efficient and so on, the longer the line of code here, especially something like this where first big indication, we have all these periods here indicating we're kind of going down scope all the time. You can imagine I might want to just put the text, once I know the text field is there for my message, I'm going to refer to that a lot of times. If I do this every time I want to put something in that text, that can be potentially inefficient, because it's like going back to the drawing board. Imagine you went to the library and you wanted to read a book, and it would be a very inefficient approach if every time you wanted to read a sentence, you'd actually go to the shelf, pull the book off, go to the chapter, find the next sentence, read that, and then put it back on the shelf. And the next time you want to read a sentence, you would go to the library, go to the book, kind of go through all that hassle of finding it all over again, as opposed to finding a reference, getting to that page and saying, okay, I'm on that page now let me read the sentences on that page. All right, so sometimes you'll want to simplify this all in terms of, don't keep finding it over and over again. Get a reference to it and then just keep referring to that reference to that game object. All right? So this, for example, if now I want to refer to that text, I just refer to the text itself, and I don't bother to go through that whole tree every time. Right? Pro tip. All right. So this is a example. Once you have the text down in the Text Mesh Pro component, you can more or less do this use this the same way, where we're adding text to some existing box. So as your story unfolds, you can add text to text that's already on the screen, or you can overwrite the text that's in a box, and so on. Right? So once you get the text component, you can modify its fields and properties. The main one we usually deal with is actually the text itself, but you can imagine there's a color property as well. There's a size, there's a font. As you get into Text Mesh Pro, you can do lots of things, change the size and so on. You can change all those as well. So if you wanted to make it much more immersive and so on, you don't have to just change the text. You can even change the appearance of the text. Right. Modifying any public fields from scripts, right? This is what we can do. And now, just examples of the different types and some of their methods, some of their properties that you can change. All right, so leave this in here as reference. So I'm going to go through these kind of quick. All right, so you've probably already built a GUI of some sort. If you haven't, or you want to get some more examples, look through here and see some of the things that you could potentially change. I want to jump over here, and then we'll kind of come back, because we just talked about why we don't want to do this and what we might do instead of that. Whoops. I feel like a marionette sometimes with all these things dangling here. All right. So, if we have a object, right, or any object, could be anything from the player, could be a key, could be a monster, could be a piece of wall, could be a treasure chest, could be a room, any object in the world, we want to have some sort of location and some method of sensing, what is the scope of that object, right? What's the size of it? Can I bump into it? Can I collide with it? Right? How many of you are familiar with the term hitbox? Right? How do I hit that object? How do I interact with that object? Right? So bumping into a wall is bumping into basically the hitbox of that wall. Right? As we kind of generalize, we want to generalize these sorts of operations so everything can be used inside Unity's physics engine and so on. It'll just kind of handle all of that appropriately. So bouncing off of a treasure chest versus bouncing off of a wall are actually quite similar in terms of the physics engine. So we want to develop a little bit of an understanding, right? And we're also going to talk about the implications for sound this way as well, right? Because we do some special things based on distance and vectors and so on. Right? So now, we want to think of the world as being 2D for starters, because it'll simplify. 3D is the same idea, except we have an additional dimension. So what we want to have for any particular object in the world, we're going to have some sort of position. Right? We're going to have an X and a Y. So like over here, the player starts off at some position, and sure, there's an X and a Y. There's no grid per se, but there is just a coordinate system, just a Cartesian coordinate system. So there's no map, there's no grid, whatever. We just say the player's at this position. Maybe the player starts at 0, 0. And typically we're going to use something called a vector to hold that. Now a vector in math and physics has some special meanings which we'll talk about a little bit later in detail. But for now, the nice thing about a vector, the vector as a class or as a variable, is that it holds x and y or x, y, and z, depending if it's a vector 2 or a vector 3. So for figuring out things like position, direction, geometry, very, very useful, right? So one of the nice things about it is we have a position, and we can also figure out distances between things, right? I'm sure you've all hopefully encountered this crazy mathematical thing, Pythagoras' theorem, right? The Pythagorean theorem, right? Figuring out that hypotenuse of that triangle, right? Figuring out that. Now, ultimately, that you can think of that in terms of a distance between 2 points that are defined, that the difference between those two has an x component and a y component, right? So in our Cartesian coordinate system with an x and a y, we can figure out how far it is along that vector by using this good old Pythagoras' theorem. So we'll save some of the ultimate implications, awesome powers, and so on. But think of positions and distances. So the center of the world might be 0, 0. There's something over here at 2.3. You know, who knows what it is? 2, 3. Monster, treasure chest, key, block of stone, whatever. Hitbox. Could be anything. Could be an audio source. Who knows? Could be anything, right? Ultimately, in Unity and other game engines, basic game objects, they all have a transform or some position where they are in the world. Right. About my personal geometry that this keeps losing my microphone here. All right. So the main thing we're going to concern ourselves with in the first project is this notion of having positions and distances. All right. So no, am I getting close to something? Am I getting warmer? Am I getting colder? Wow, this is out of whack here. Lose my glasses. So I'm getting closer to an object by decreasing the distance. Getting further from an object, the distance increases, right? None of these things are quite yet rocket science, but we'll leave the rocket science for later. Now, one of the things we can do once we know a position like that, and I guess I'll erase this here. All right, I do have an example on there. Won't worry about drawing it too much. So imagine the case of a room, right? The idea in our game is we want to say, well, we have the player, and we want the player to be within a room. And for now, we're going to do the simple thing. We're going to say the room is rectangular. So the room has an x dimension and a y dimension, or perhaps it has 2 corners in the world. So one corner which has a position, and the other corner has a position. And me being a good math student, I can say, well, okay, if I have those two, and I'm in some kind of Cartesian coordinate system, I can look at the difference in x and the difference in y, and that'll tell me, you know, something about the dimensions of that square I'm in, right, the rectangle I'm in. Easy enough to figure out. So imagine I have a rectangle, or corners of a room, that are defined by these 2 points. I have sort of a lower right and an upper left. Lower right, upper left. That sort of thing. And because I'm saying it's a rectangle, that implies that there are 2 90-degree things going on. They're corners, right? They're 90-degree angles. And then if I project lines out from there, it forms a nice box. Right? Anyone want to fight me on that? Nobody? You want to fight me on it? They are. My box is a pixel, for starters, right? And that could happen, right? This is a very, very tight corner, right? So, yeah, this is, I forgot, I should have changed that. I keep meaning to change that. Problem is when I'm in presentation mode, then it throws off my mojo. But yeah, ideally what you want to do is they should be different, right? So we think about, you know, how do you want them defined? So to be meaningful, to have some area that you can actually be inside, it'd be good to have them different. So imagine here we have a set of corners or potential corners here. 2, 3, that's one corner. -3, 1, that could be another corner. Whether or not it's a corner and what direction the corner is going to sort of depend on what other dimension or what other corner I pair it with, right? If I suddenly said, okay, one corner's up here and one corner's down here, well then I want to figure out, okay, am I between those two versus if I'm down here, I have to figure, right? So it can kind of change a little bit. But you can imagine if I asked you, is position 0, 0 inside the rectangle defined by corners -1.5, -2.5, and 2, 3. Is the center within those two things? Right? Certainly seems to be, right? If this is one corner, that's another corner, that seems to be in the middle of it, right? How about in between -3, 1 and 2, 3? What is it? Is it in there? No, right? Because this corner then becomes a lower corner, and 0 is below that one. Right? So congratulations, now we know the basics of a hitbox or a box collider. Right? This is one of the, not the simplest, but one of the simplest sort of collision box or colliders. Right? Now, when we get into Unity, we're going to let Unity really do it for us, but for now, it's kind of useful to understand, what's really going on, and we're going to kind of implement it by hand a little bit. All right, so if we wanted to confine movement, we want to confine the player to some area, we don't want to let them leave that area, we might want to do something like, for example, don't let the player move out of that room. Now, we're going to assume here player position, player pos, has been defined as a vector2. So it has two components, as an x and a y. Right? That can be any arbitrary number. And we have the lower right x and the upper left x, and the lower right y and the upper left y. So we have to figure out, okay, we want to confine the player, their x and y value, to be between the corners of the room. Right? So we're going to use a library function. There's a library called mathf. It's a floating point library. There are a bunch of things that mathf will provide for us. Random values, rounding, all kinds of fun stuff. Oh, no. Well, I'll come back to what other things are in the math library. But one of the things that you're going to want to check out is this idea of clamping. So what clamping does, it says, all right, give me a value. This first argument is the value that I'm interested in. And give me two constraints, a lower and upper constraint. And what I'll give you back is that value, if it's between those two, or the lower upper limit, depending on if you've passed the upper limit or you've gone below the lower limit. Right? So if I had a line, I could say, okay, as long as the value you pass me is within that, I'll give it back to you. Otherwise, I'll give you the extremes. So it's a convenient way to keep a value from going outside that range. And if we do it in 2 dimensions, voila, we can constrain any position to be within a hitbox. Okay? So clamp keeps the value within the range. I'm going to use this floating point math library, mathf, for now. So convenient way to keep us inside a box. Now, notice that doesn't tell us necessarily, are we in the box, are we out of the box, and so on. You'd have to do a little bit more comparisons, a few more comparisons to say, okay, did the value change? If so, that means whatever value I tried to go to was outside and needed to be changed. Right? So we may want to take advantage of that.
Do you need to put that line in every time you want to put someone back in the box, or do you just say it once and then everybody goes?
No, that's going to be executed once. This is all a line of code, a statement that's happening once, and then you go and, depending on, it's not automatically applied, right? Yeah, every time, well, ultimately here, every time the player takes a turn and tries to move, right? So if you had the directional pad on your screen and you say, okay, I press the up button, and what that means is adding 1 to y, or there's a down button that says subtract 1 from y, or there's a left or right, add 1 to x, subtract 1 to x. After you do that, after you try to apply that, you check or you enforce that, right? And you may need to say, well, if you want to have a sound effect because you hit a wall, well, you might want to compare your value going in versus the value you got back and say, well, if they're the same, I didn't hit anything. If they're different, if it changed the value, it means I hit the wall. Okay? Does everyone get that one? Right? So I could say, useful thing, say, okay, new value equals player's position plus whatever offset I wanted to make, right? So player's x plus whatever. They can move by 2 because they're running. Maybe they can only move 1 because they're walking. So I'm going to come up with some new value for that. And then I'm going to run through this and say, okay, is the new value the same as the old value after passing this point? And if so, well, then I hit the wall. Okay. So checking distance, we're going to rely on good old Pythagoras here. But one of the cool things that we're provided with in C# and in the vector class, because as you can imagine, as we get into vector 2s versus vector 3s and so on, it'd be nice to just be able to say, well, what's the distance between the two? What given this vector 2, given this vector 2, given this position, what is the distance between those two things? What is the magnitude of the vector that points from one to the other? Right, that's what we're referring to in more straight mathematical terms, right? If I have something here and I want to move to there, I basically have a vector that points from one to the other. The vector has a direction and a magnitude, so I'm asking, what is the magnitude or the distance between those two? Right? So to figure out a distance between 2 points, I can just say vector2.distance and give it those 2 points. Because in this case, we know that x and y are perpendicular. That's kind of the way it is. That's the way Cartesian coordinates are. We can use, or in this case, Unity will be using our good old friend Pythagoras' work to help us figure out the distance in between the two. So if I knew that the player was here and the monster is here, I can figure out, all right, the distance between the two, and then make some decision based on that distance. I say, well, if the distance is greater than 5, well, that's the distance that the player can see. The player can only see by 5, so the player can't see the monster, for example, right? So sensing all comes down to sort of applying distances and some imagination to say, all right, we have some radius of sight, perhaps, or smell or sound, and so on, to figure out, how far apart are these things. Now, you might have noticed I said a moment the radius. I let the cat out of the bag on that one. So boxes are great. We love to collide with boxes because we can figure out, one and the other. But I said, well, it's not boxes weren't the simplest thing. Of course, the simplest thing to collide with is a circle, right? Because all you have to do is figure out how far away from that circle you are. If you're farther than the radius of the circle, you know you're not in the circle. If you know the position of the circle and your position, 2 positions in the world, you know the radius of that circle, you know the distance between the two. You say, well, if the distance is bigger than the radius, I'm not in that circle. Right? Following that one? Everyone good? Right? The radius is greater than that, I'm outside. So once you know that, you basically have a circle collider, a primitive circle collider, a circle collider against a point you could have. And then you could go a little further and say, well, if I want the collision of 2 circles, not a huge jump, you just say, well, it's the radius of the 2. So you could say if you're within the distance of the radius together, we can figure out if our 2 circle colliders are colliding. Right? Okay. So the idea is that we want to use those sort of colliders really to figure out in our world what's what, where things hit, and so on. So in the good old simple case, the watered down project, we said, okay, we have a room that has corners. Have the player somewhere in there, and the player is going to be moved, and by moving I just mean changing a vector that represents its position. I'm going to move it around, and I'm going to check. I'm going to constrain it to be within that room. And then I would have some objects like here's the key. And I would see, okay, based on, I'd have a small radius for each of them. I would say, well, how far is this from this? Gives me that distance. If that distance is less than this plus this radius 1, radius 2, right? If the distance is less than those added together, then I know that they're touching, right? So this was the simple version, right? You have one rectangle, one circle you can sort of collide with. And then you could go further to say, okay, we have a key, we have, ultimately, maybe we have a treasure chest over here, which is, maybe another circle. And then maybe we have a door over here, which is a point with a circle collider on it. You'll see as we get into actually designing games in Unity, a lot of time it's really just figuring out, where are these objects, what type of colliders do they have on them, where do we bump into them, and so on, right? You may have, if we want to get fancy, there's always the question of, like, are you inside a box, are you outside the box, right? Pretty easy to say, well, the opposite of inside is outside. So we can negate whether we checked, we could say, flip the value. So the simplest hit colliders, and that's sort of the basic thing we're looking for in the project. And to do that, of course, requires a little bit of state in here, right? So the classic one, these would be sort of the main properties of the game. Or inside of the game manager, we would have these fields defined, or these properties defined inside. So everything's still inside of our game manager. We have the player position, obviously. We would have world corners, and there should actually be probably 2 vectors here, one for upper left, lower right, depending on how you want to define things. So we have those corners, and then perhaps, like in my version, there was like a flashlight that you could use, and the flashlight would have to be lit or not lit. So you'd have to know, is the flashlight on or off? So the flashlight's state would be a Boolean, it's on or off. I might have an integer saying how charged is the flashlight battery. So I might have 10 uses, so I'd start off at 10, and every time the player takes a turn with the flashlight turned on, it would take one of these battery charges down. I have score, maybe I have health. Every time I bump into something or bump into a wall, I subtract 1 from health because there's an electric fence, maybe. Some kind of goal position, which might be, in our case, the door over here, right? Now, here's where you start to get a little bit more complex, and where I think what people wanted to do is get even more rich than this, right? Maybe more complex. We have obstacles, which might be walls, might be other rooms, right? You can imagine somebody wants to do this. They want to say, all right, I want a room here, and I want a room here, and with a door, and I want a room here with a door, and I want an object here, and an object here, maybe there's another object here, and so on. Right, so we have a lot more things to keep track of, but they are extensions to those basic ideas, those basic collisions. Right? So you have to figure out, all right, is the player staying inside this room? And then, well, if the player tries to move in some way that moves them outside this room, does it move them inside this room? So you have to sort of potentially check multiple things. The brute force method might be, well, if I know there are 3 rooms in the game, let me check where the player is. What room are they in? So I'd have to run through some sort of loop, some for loop or while loop or something to say, let me check all the rooms in the level and see which one the player's in. And if there are none of them, well, that's a problem. I should have never let them move, perhaps. Right? So Normally, I like to keep it simple because we haven't talked about arrays and lists and collections yet. So, because I don't want to dampen the enthusiasm too much, I will offer up the following. Okay. And this actually worked out well last semester, so maybe I should just make it a permanent thing. The next game that you're going to do, the apple picker game, is sort of cut and dried in certain ways. There's not a lot of design you necessarily need to do. We're really going to focus on introducing gravity and some more game objects and physics and things. And there's not a lot of design to do, depending. You can get pretty creative in terms of what's dropping, what's being caught. You know, there are other things, are there deadly objects and all that sort of thing. But it's been, in the past, I've waived the design phase for the second project, which would allow us to get a little bit more time in terms of finishing the first project. So I'm not saying you have to, and if you're already down the path, and we can certainly, one room is good enough. Following the design as is good enough. So don't worry, I'm not adding requirements. I'm just adding options here, so that if we move the deadline for project 1, or basically what I'm saying is I will not count a late project against you if you decide that you want to use arrays or use something to make your environment more complex. Because enough people wanted to go down that route. I can see that being a little bit more interesting, if you like. Okay. So does everyone know what I mean in that case, right? So if we're back here, we're looking at pushing back the project 1 due date by, over to I would even make it Saturday after this, right? So if you want to make your environment a little bit more complicated. However, I'm going to highly recommend that you shoot for having a room, an object, kind of the basic case of it working before you expand it into the multi-room, multi-object, kind of make it more complicated. So in theory, you should still have the basics, in terms of your own time. I don't want this to be just like, oh, okay, just push everything off. I don't have to do any work until, the next couple of days pass by. I want you to have still implemented the basics more or less this week. Get some collisions working, or some pseudo collisions working, get the UI kind of doing what it needs to do. But if you want to expand upon it, then you take some extra time to do that. Sound good? Reasonable? Right? It's the first week back. It's confusing. It's COVID. We've all been in quarantine, whatever. So we'll loosen things up. So don't worry about necessarily this deadline. We'll just move that and give you some more time to kind of settle into things. Right? So there won't be an official design for Project 2 because the Apple Picker, you'll see, it's basically a Kaboom-style game, arcade action kind of game. And it's pretty straightforward. You'll decide. There will be some things about the design, but that'll work out, and you'll get the points for it. So don't worry, I'm not going to take points away. Right? So you'll get the points for the design as long as the game, there'll still be 10 points for the. Come on in. The challenge of this wood block and whatnot. Oh boy. Now you're in this room all day, right?
Yeah.
Okay.
Actually, went the wrong room now.
Oh, that's no fun. Keep that open. Is our TA Justin? Justin, this is everybody? So we were just discussing, letting the cat out of the bag about relaxing the deadline on the first project because everybody wants to push the envelope of what the first project is. So we're going to broaden the scope a little bit, add a little bit of a buffer, see if you want to, how far you want to scale back, push up, and so on. So we'll more detail on that, and also give us a little bit more leeway. How many of you have conquered Perforce, submitted Perforce Everybody thinks they have? All right.
Fine, Tom.
You have looked at the depot. There's a workspace tab and a depot tab. And when you look at the depot tab, you see the stuff that you see under your name. You see stuff, right? So that's sort of conquered, right? You won't see everything in your Unity folders because not everything should be copied up to Perforce. That'd be wasteful, right? There's lots of temporary crap that Unity keeps locally and cached and so on. It only wants to keep really the important stuff that needs to be stored and saved and documented for the long run. That's the stuff that winds up being persistent in Perforce. So we'll double check on that as well. Okay. Let's see, am I still? Oh, I actually am still recording. That's great. Okay. So here we are. Now, like I was saying over here, in order to really get into this notion of having rooms or multiple things that you want to encounter, and have you picked this thing up? What's in your inventory? Is this thing in your inventory? Is it not in your inventory? And so on and so on and so on. You're basically kind of creating more state that you need to keep track of in your game object, in your game manager. So for that, we'll talk about arrays a little bit more than, or earlier than we do. Usually we kind of push that into the second project, but we'll get there a little bit earlier. So we'll it'll work out. I think it'll be fun and make project one a little bit more satisfying, right? So again, making sure that everything is kind of, we're dealing with things in a bit of a brute force way, right? After this, we're going to let Unity do most of the collisions for us. But for now, we're walking a mile in Unity's shoes, sort of. Okay, so imagine we have extra state that we want to keep track of. Is an obstacle active? Did you kill the dragon, or did you kill the this orc, or whatever? Did you find the key? Did you reach the goal? Did you open the window? So on, right? You have some more complex state that you may need to keep track of. Here, sort of our basics. All right. So what do we do with that data? All right. So imagine that this is obviously graphics here, and we don't have graphics in our game. But the idea, I just want to illustrate it. You'll notice that there is a spot in the middle of the screen, our little character, our adventurer in the middle of the screen that has a location. Happens to be, we see a coordinate system just for the sake of knowing that there's a coordinate system there. He's not on, or it's not on a particular square per se, right? Just has a location. And what we're going to do is we're going to give that character a sense of sensing, a sense of sight or hearing or smell or whatever, right? So often sensing in games is conditional based on distance. That makes perfect sense. You can't see infinitely, can't hear infinitely, right? So you have some distance within which you sense something, right? That's why circles come in real handy for this. So vision might be affected by distance and lighting, for example. So under dim lighting conditions, we might see 5 feet around us. In brighter lighting, while we're holding a light source, we might see 20 feet around us. So in your game, you might say, well, while the candle is lit, I can see 5 feet away, or 10 feet away. While the candle's not lit, I can only see 5 feet away. So if you get within a certain distance, close enough to the monster without getting too close to the monster, you can sense them, right? Likewise, hearing might be affected by distance, with the volume decreasing as we are further away from things and increasing as we approach them, right? Some people had asked or kind of talked potentially about using spatial audio in their games. And Unity has a spatial audio engine that it can do all kinds of great stuff for us. We're not going to use that yet because we're doing it the brute force way to get an appreciation for it, right? So what spatial audio does is basically it's kind of continuously changing mix levels, right? Saying, okay, more of the sound is coming out of this speaker over here. That gives us the sense that the sound is over here. Or maybe we change attenuate the levels and we put it in this speaker over here so we get a feeling for where it is, right? So we're going to do a simple one-dimensional version of spatial audio in our game, recommended, in that the further you are away from something, the larger the distance is between you and that object, that audio source. Within your script, you're going to change the volume of an audio source component, right? Components just have, they're just properties, and audio sources just have a property called volume that you can change. So every time the player takes a turn, changes its position, you can calculate the distance between the player and whatever that thing is that has audio. Right? So you use that position to figure out how loud should that sound be. Right? We can do all sorts of things, like even simulating other senses, other extrasensory ones. We can say, oh, I sense temperature. Is it warmer? I got closer. You feel colder. You moved away. Right? So everything is descriptive now. So your spider sense tells you we can do all that sort of thing. Right? We won't have to worry about design issues of how do we really present that, how do we visualize that, because we're not visualizing anything yet. We're narrating. Okay, so it should be all about the text in here. So the one thing to come back to, and I think most people got this idea correct, is that the game is really meant to be turn-based. So we have a start function, and then every time the user presses a button, takes a turn. There's an action, right? Dungeons and Dragons style. How many of you played 5e, right? I guess 3. All kind of using this system now, right? You take an action. You take your action, your turn is done. Maybe you have a reaction, maybe you have a bonus action, but for now we just have an action. So we wait for the player to take their action, then we update everything. We say, okay, here's what happened, right? Once the player moves, then the monsters can move. They can't continuously move while the player is thinking, right? It's only on their turn does something happen. So it's our turn, we input things, the game takes its turn, it's our turn again, we input things, and so on, right? So we don't have to use timers, we don't have to use the update loop. We're just using every time an action happens, so we sort of have to build our turns into that action thing. So after a player takes an action by pressing a button, we need to let them know what happened, what changed. Right? If some value was X and now it's Y, let them know. This can be directly by text or indirectly by some other thing. Like perhaps, if you want to, and there is no requirement in the first version. Some people have asked about this, some people have implemented it. Have moving obstacles, have moving monsters, things that move around in the world, right? Definitely can get more challenging. If you're feeling, bold and have some ideas on how that works, you're basically creating, AI on the fly a little bit. But for starters, I recommend just saying, well, have monsters that stand still and you encounter them when they get there. So they don't really take a turn, they just kind of stand their ground. The stand their ground game. If you're really feeling ambitious, you could do that. But imagine, on your turn, we just do, say, okay, what is the new distance to the zombie? This should have all been jammed together. Sorry. Somehow took Unity's lead and spaced things out. But imagine my new distance to the zombie is equal to my player position, my zombie position. I take the Vector2 distance between those two. Right? So now, after I've updated the player's position, I can check. Did I get closer to the zombie? And here's one of the core things, the hotter, colder, sensing, and so on. That, okay, if the newer distance is less than the old distance, which implies somewhere I've kept track of that state, right? State is things we need to know about so that state changes, the game progresses, something happens, right? So last time around, this is what the distance was. This time around, this is what the distance is. The distance has decreased. The new distance is less than the old distance, so therefore, I need somehow, and this is just shortcut here, imagine somewhere on the screen there's a text box, and I say, well, I better put in that text box that you feel a chilling presence more strongly. Right? Or maybe I turn the text blue and say that. Otherwise, I could say, well, if my new distance is greater than my old distance, meaning I've moved away from it, right? That's okay. But I want something, this is kind of interesting here. It says, oh, well, last time around I was within 5. So there's a kind of 2 things going on in this state. I'm saying, all right, if I've moved further away from the zombie, but last time, or at some point, or maybe I still am, actually it's not last time, it's currently am, so I'm within 5, but further away. So it's sort of a near miss is what happened, right? I said, okay, I moved further away, but I'm still kind of close, so I'm kind of like on that border, right? I've moved further away, but I'm still within the odor, right? The presence, that aura that it has. We're basically saying that if this distance is less than 5, there's some sort of aura, right? I'm within 5 meters. Unity is metric, by the way. So whenever I say 5, I mean meters. You can change it. Well, gravity is 9.8. So by default, we're talking meters. So if I'm within 5 meters, I'm always sort of on the edge. And in this case, I say, well, okay, I moved further away, so I sense that avoided danger, obviously. And here's the very important part here. After I've done all my checking about the new things that have happened, my old state or my new state becomes my old state, right? This is my memory of what happened. All right, so quite often you're going to want to say, okay, after calculating everything, update the state. That's why I have an old distance here, and first time in, I'm always checking that new distance. See what potentially changed against the old, and then make the old or the new the old. Big hint on this one. Dynamic audio. I want the feature points for that. So imagine we have a heartbeat. And how would we create a heartbeat? Does everyone feel? Let's see. Let's have an exercise here. Exercise to try. You have, someone wants to be my friend. So here in our game, we have one of the things you're going to want to do. And right now, imagine this was our game. The main objects that I'm interested in, of course, the game manager, and then there's the canvas with all the buttons on it. The one other object or set of objects that I'll let you put, because quite frankly, it's easier to deal with it this way, is the types of sounds that you want to have in your game. The ambient sound versus the sound effects and so on. For sake of expedience, and here, it's easy just to create them as their own audio source objects. Don't put them on the canvas. Just make them distinct audio sources within the world, right? We'll just make that easy. And the other thing about that is if you do wind up, I think, did I leave one in here? That was the other. Let's see. Just happen to have some sounds kicking around in another project, so I'll grab one of those. So I'm going to grab this and put this sound effect. So once I have sounds, and go ahead and grab sounds from the internet or record them, steal them, whatever. I don't know. It's sound effects we won't worry too much about. Background music, try to find things that aren't copywritten, so don't get pop music and whatnot. But this is just a wave or an MP3. I think there's a wave in here. And if I play it, good question. Get that. That was me. Sure it was. May sound familiar to you, but anyway, we'll just leave that in there. This is just an audio clip. So it's the actual audio file, a wave file that I just grabbed from somewhere on the internet. It's not an audio source. It is a clip that I've put into my asset folder. Now, if I drag that into the game, or even anywhere into the scene, so I can drag that audio clip up here, it will create a game object for that with the same name. And it will even create a audio source component on that game object for me that references the audio clip. Right, so we're seeing a little bit also, again, back to our hierarchy and how Unity does things, and sometimes it'll do it automatically for you there. So it's created this audio source object that has an audio source component on that references the actual do sound that I had here. Right? So when I dragged it in, that's not really the audio clip. That's actually an object that Unity created for me that has that component that references that clip. Kind of crazy, but that's how it works. So once it's there and I press play, it's in the scene and it's an object that is valid, so it plays. It does its thing. Right? By default, that's what an audio object does, an audio source does. It plays that clip. So let's look at a few things about that clip. You'll see all of these, or excuse me, that audio object here. You'll see immediately that it has some settings. The one that we're mostly going to be interested in is this volume, right? So I can set the volume of the clip, and then when I play, here it's less, lower. But it plays it once. It plays it immediately. These are properties of that audio source, and I can change them. So imagine that I didn't want it to play immediately because, well, it's only supposed to play when I bump into the wall, for example. Over here, another two important things beyond volume. There is play on the wake, which says, does it play immediately? Right? Does it imply that it should be played immediately? And then it also has loop. And if you set loop, the sound will play over and over and over again. Useful for background sounds, dynamic things, ambient sounds, heartbeat, foreboding in the distance, and so on. You just have things set to loop all the time. So instead of having to trigger an audio source to play it, use the play method of the audio source, you can just have it play on awake and adjust the volume, and it's kind of always there. It's always present. It's always your background music or ambient sound, right? So little side track with audio sources here. Right, so to do dynamic audio, once you have a thing that's playing over and over again, and let's see, do have something a little bit more. I'll use heavy rain here. All right, this is a little bit more game appropriate. So I'm going to grab this and can't drag it over here. Can't actually grab it in here because I can only add waves, audio clips to my assets. I can, once they're in there, then I can drag them from here into the scene. So now this will play on awake and I'll have it loop, and hopefully it's not too loud. So I'm varying the volume now. Imagine if I was... The storm approaches. In the distance, I hear it. It's approaching. Oh my gosh, it's upon us, right? So by dynamically changing the volume, I create that sort of spatial sense of audio there. All right, so now I've got two audio source objects here. One that I want to have only play. I'm going to turn off the loop on that because I only want it to play as necessary. And the other one is my ambient sound in the background, which is playing the moment the game starts and looping over and over again. That's the one that I'm going to then be manipulating my volume of. There are other things we can play around with as well. Sometimes we can play with the pitch to make things sound faster or slower or higher and lower in pitch. And you can change the stereo panning, and so we won't worry about, like I said, no true spatializing just yet. So if you want to play with volume and pitch, those are two good ones. And this is how you would do that in code, changing the volume. So try varying the volume of a looping audio source each time the player moves to create a sense of proximity to an object. So we'd have to have an audio source somehow that we could reference. And once we have a reference to that audio source, we can set its volume. And this is an inverse relationship, right? You want something to get louder as you get closer, which means the distance is getting smaller. So the smaller the distance, the louder the audio, the louder the volume. So we have this inverse relationship we need to do. So, excuse me for just a second. There we go. Just got a hand sanitizer right here. Okay, so we're going to use an inverse relationship here, and you may have noticed that when I moved the audio, the volume up and down, it went from 0 to 1. 1 is full volume, 0 is fully attenuated or fully off. So I want to be able to create this little algorithm here to say I want my volume to change to be able to be changed between 0 and 0.9. I don't want, or it could be between 0 and 1 if you want full loudness and so on. And we're going to use, to set that value, initially we're going to say, well, we have, and this will depend, this will depend largely on how you want to tune your game, to say, okay, how far away is far enough to hear the sound versus how close do you have to be to get the full volume of the sound. So in this example, it says, all right, you have a distance of 4. So if you're 4 away, this will become what? 4 over 4 becomes 1, right? It's actually going to wind up being clamped to 0.9, so we're not going to make it full volume. But so if I pass this 1 and I give it, clamp these two values, it's going to become what? What is the result if this is 4, what's the result coming back from math.clamp? Yeah. 0.9, yeah, 0.9, right? You say, okay, it can't be 1 because that would be outside of this range, so this function is going to return 0.9. That 0.9 is going to be subtracted from 1 to give us 0.1. So it's with a distance of 4, our value becomes the maximum, which is the quietest the sound can be. So once we're beyond 4, the sound is as quiet as it will ever get. It doesn't go negative, right? As distance becomes 0, we'll get 0 back here, and the sound volume will go to 1. Right? So the closer we get, the closer to 1 the volume will get. The further we are away, the closer to 0.1 the volume will ultimately wind up being, because it'll be 1.0 minus this 0.9. Right? That makes sense? All right, so this is the blueprint. You got it right here. So that is sort of the key to a lot of the features of the game now, right? UI, we demonstrated our slider, we demonstrated our buttons, did we demonstrate the toggles? Did we do toggles? Let's jump back over to the game. Let's see what we have here. Not that. Over here. Okay. So we have a game. We had buttons on which we had, of course, the button. We had a on-click event. We had a slider which had the on-value changed event, which is going to potentially pass us, if we want it to pass us, we can get the actual value of the slider, right? If I look in here, I see Game Manager, and I see that I'm using the dynamic float version and passing that to my shock the player right? Did we see that part on Tuesday? Was it Monday, Tuesday? What day of the week? One of those days. Last week? Friday. My gosh, I'm totally lost. First day of class, like I said. So as the value of this slider is changing, it's being passed dynamically to this function here. If I had used this version, it would only pass it this predefined value that I would set, which I don't want to do. I want to use the dynamic float version for shock the player. So when I press that, that's changing. For a toggle, see here we have a toggle which has some, its appearance, but the important part about the toggle is that the toggle also has an on value changed, just like the slider did. But a toggle is just a Boolean. It can be either true or false. So we can use that to call some action in our game manager. And we'll see if I drop that down, game manager, I can see that there is a dynamic, or there's a function or method that's called toggle action that takes a dynamic bool. All right, so on the fly, I can determine, should I turn the flashlight on or off, right, for example. So let's wire some things together. I'm going to wire for the heck of it. I'm going to say, well, I have that cool dope sound. It seems like a good reaction to being shocked, right? All right. And this slider over here actually probably be better suited, rather than just changing the shock value, we'll use that to change the volume of our thunderstorm in the background. Right. So shock the player is calling shock the player, the function that takes no value. And this one will, currently it has shock the player that takes a floating point dynamically. We don't want to do that. So let's, for a moment, go over, find our game manager if we wanted to, double click on that, go over to C# here. Now, in order to play that sound, that dope sound, I need a reference to it. So I have two options. What are my two options? What are my two options to get a reference to that game object? Yes?
Well, write it down as like a game object, and then like, I don't know how to describe
Drag and drop?
it. Yeah, drag and drop.
Okay, that's the first one? Right. So I can either use GameObject_find, right, referencing, asking the GameObject class to find that object of that name, or I could do the drag and drop method. So let's, in either case, I know that I do need a reference to the game object, or I'm going to want to have a reference to that game object. So we'll say game object shock sound. Now, if I want to do the drag and drop approach, I have to make sure that that is public, or what else? What could I do instead of making it public? Anyone remember? The more appropriate thing to do is this magic bit called serialize field. That's another way of exposing that field to the Unity editor. So the moment I say this now, if I come over to the Unity editor, we'll see now that it has, compiling, it will say shock sound. Okay, so we have the ability to set that reference. I'm going to drag dope over to that, set that reference. So now my shock sound variable, the reference to that points to that other game object. Come over here, and now we can use it. We can do things to it. And we're just going to come down here, and we had shock the player. So we can use, where is it now? Shock sound dot Now, that's the game object, right? So we know the game object, that's the shock sound. We don't have a reference to the audio component yet, so we have to say, well, we want to get a component of that object, get component. The component we're interested in is, of course, the audio source. All right, so that is how we would get the audio source component of this object. And now, the last but not least, is that there is a method called play. So we're not going to call that shock the player. Instead, we're going to say right. So that's how we would call a method of the audio component that's on that other object and get it to do the right thing. So now, when I come over here, okay. Poor Homer. Okay, so there's that. All right, I'll let you extend that to your heart's content. But the one other thing I want to show in the code here, and unfortunately I don't have a slide for it yet, but based on, again, based on people wanting to do more complex environments like this, and the notion of saying, well, okay, I showed you what the state would look like in some of these cases, and the sort of thing we want to keep track of. I'm going to show you just a little snippet of code, kind of open the door for this, and say, well, imagine we have our game manager class here, and the cool thing, the game manager class is also defining a namespace that we can kind of work within. So there's a little sandbox that we can play in here. We can define other structs, we can define other classes all within that scope. Right? So you'll notice here, I have created another little class. And there's actually even another little my type enumeration in there. So the reason I did this, I said, well, all right, say I want to have a key, and I want to have a treasure chest, and I want to have a zombie, and I have whatever, all these different things. They're basically all going to be hitboxes of sorts that I'm going to need to collide with one way or another. Right? So what type of things do I need to know about them? How do I define the hitbox for each one of those? I'm going to say, all right, well, I need to know its position, right? And then once I know its position, what else do I need to figure out, potentially if it's a hitbox, how do I collide with it? Now, if it was a rectangle, what else how did I do the room, the rectangle? What did I have? I had top left and bottom right corners. So I could say, well, the position defines one of those corners, and somehow I need another corner, right? So I'll use this bounds to determine the other corner, right? So instead of an upper and lower, I kind of have a position and then the extent of that box. Effectively the same thing as having an upper left and lower right, except I've kind of shifted my box, right? Sometimes you'll see different systems that do it this one way or the other, right? What I mean there is that whether I say here is the position and here is the bounds, as opposed to here is the position and here's the upper left and lower right corners, this is just a slightly less efficient way of saying, I can, well, okay, two values I can have that box. One is the position and one is the bounds, okay? And then I have a type to say, okay, that's a square, a rectangle, or a circle. Now, if it's a square, I would really only just need to have the x value, because x and y would be the same. If it was a circle collider, I would just need the first value and say use that as the radius, right? So I could say, well, okay, the position is here, and there's the radius, and that gives me my enough to do that, right? So I've created this little data structure here that defines a hitbox or an object. I could extend it even further. And the one important thing about this object, this class is going to say, okay, I want to know, does this hitbox contain the point that I'm handing to it? So I'm going to create a method, a public method for that little class in there that's going to say, okay, give me the point, and then figure out, there's no code in there, it's all just left empty for the moment. And say, okay, do that, figure out where it is. So an example of a little class that I can create in here that's going to say what my object is. So I'd have one of those for, I don't know, every room potentially, or a set of rooms, a set of objects, right? But how do I have multiples of that? So I'm going to introduce this real quickly. The concept of arrays. We'll talk more about this, but if you're getting ahead of, you want to think of things. Arrays are just going to be kind of multiple ways of storing lots of these things. We're quickly running out of time. So imagine I wanted to have 16 hitboxes. I would use an array of hitboxes, or I could use a list, but I'll use an array for this one. So I would use this following line to say, okay, this is saying type hitbox, an array of hitbox. We have our element defined, our element parentheses here. We're going to call them all boxes, and we have to initialize them because arrays in C#, especially if they're within a class, they are references. So we have to use our new to give them, to set them up. So this sets up 16 potential hitboxes. Now, those of you who want to get real fancy, you might have one array of rooms, an array of monsters, an array of magic items, an array of walls, right? And each one of those things is going to have a hitbox associated with it. And then ultimately, instead of just doing the easy route and saying, okay, is the player within this one hitbox, you have to use something like a for loop to say, let me run against all the hitboxes and see, did the player hit any of those, and take the appropriate action. Yes?
Can you do that in like a less expensive way?
Yes. Lots of ways. Important things is you might say, okay, well, let me, at the initialization of the game, knowing the player's position, let me find the first one that they're in. And then as long as they stay within that one, they don't move outside, I don't have to check the other ones. The moment they step outside, well, then I have to check the rest of them to see which box is it now in. And once it stays within that box, and so on and so on. There's other optimizations like compound colliders, which we'll see Unity implements for us later. Lots and lots of different ways to do it. But they all build on the same concept, and ultimately they kind of optimize based on assumptions that they can make, like it can only, the player can only be in one position at a time, or this group of things, right? It might say, this is how Nanite and how Unreal and all these things cache things. It's okay, I only have to check the objects that are within this room to see, because the player is within this room. I don't have to bother checking those. So there can be some more sophisticated data structures and trees and so on that take care of that. Okay. But I'll stop there. But just to let you know that this is going to be, if you want a complex environment, you're going to have to manage all these things, because we want to do it. We're kind of thinking a little bit like a game engine. It's the goal behind this, right? So we have to appreciate what Unity is doing for us first by having to do it ourselves. Okay. And the cool thing, of course, is you can even have arrays of things that have different types of hitboxes and different size hitboxes. And so you could say, well, I define the world by, the world is overlapping circles, kind of weird shapes, right? This room is comprised of these hitboxes, right? So you can have unusual shapes and so on. Through creating these combinations, creating these arrays of hitboxes to check, right? Kind of stacking them all up on top of one another. Yeah?
Is there any place you could publish this code or something? So I could look over
This will be, I'll put another package together that will include this. I'll clean it up a little bit after today. And there'll probably be some, I always want to clean it up a little bit based on the second class of the day. So it should be available sometime tomorrow. Right? Okay. And eventually, I'll put either the AM or PM depot will have some reference code in there for you to look at. So don't worry about snapshotting it down, and just get the concepts. Think about the concepts right now. Revisit your game designs to see, okay, now how would I approach it, right? What do I need? How many arrays do I need? What are the extents? How many objects? And don't get too carried away, because we're not talking about 4 weeks for the project. We're talking about a week and a day or two, right?
Yeah,
So
I can already tell it's definitely got the downscale.
scope down, right? Save the exciting stuff for project 3 and 4.
Yeah.
Okay. All right.
Thank you.
Thank you very much. 3 minutes to spare. Good luck getting to wherever you need to. And we'll see you on Friday.